One thing that always amazes me whenever I teach a class or give a presentation, I know it's kind of a Murphy's Law kind of thing, but I always find some subtle bug that baffles me for moments. I figured out yesterday my trouble with doc tests while Yuli and I worked on it afterward. And you remember how I had a doc test and like it said inconsistent indentation at the beginning? It was like I indented it all, and I was like, I don't remember having this trouble with doc tests. Like it's not really that picky on your leading spaces and whatnot. I apparently haven't made doc tests that check for the presence of an embedded new line, or at least not anytime recently. So Yuli was trying to make some doc tests herself, successfully, I might add. And what was tripping me up was my embedded new line. And the reason it was tripping me up is because there's essentially double execution of this string. And I think I understand now what's going on. But if you're normally going to specify a literal /n character in a string, you can just say /n. I have a string that's embedded inside another string. Right? This is in triple quotes. So the Python doctest module takes my doctest and reads it as a string, at which point it evaluates /n and puts in a literal new line character there. It then tries to run my test and says, I have a console line that looks like format line, and I'm expecting to get back opening quotes, return, and a closing quote is down on the next line, which it doesn't like. So I had to double quote my /n, and as soon as I did that, all the non-helpful error messages about leading indentation in spaces went away. Yeah, so if you've done string slashing in strings, maybe I should explain that too. If you've done escape characters in strings, if you want to embed a literal slash, a backslash in a string, and you're using backslash as your string escaping, you have to escape your backslash. So 2 backslashes in a row would be interpreted as one single backslash. So the first time it's evaluated, the doctest module now gets this and sees ABC/n, which is what I wanted to pass it. And it evaluates that string. So it's because the string is evaluated twice. And actually, when I had to do a quick Google search to see what the heck was going on, and lots of people complaining about having Control-R, Control-T, or Control-N in their doc test. And it's like, ah, right, I get it. There's 2 executions of this string, basically. So a little tripped me up, and it points to something I did know about doc tests, which is, in general, you should condition your output to be as simple as possible. Danny was asking me about order of dicks. He was printing out his keys and noting that it was always in the same order, but it was kind of an unusual order, no logical reason for it. And dicks are unordered. So if you have a function that returns dicks and you're checking the return value in your doc test might fail. You have the right keys and values. They're just not in the same order. And there's no way to guarantee that they would be in the same order. And in cases like that, I might see that I have the right keys sorting the list first. But in general, doc tests should have really simple output formats. So let's talk about new stuff today. So we're past. I mentioned we're skipping regular expressions. I'm probably going to come back and talk about the option parser module because it's such a useful module, which is section 11. I use optparse all the time. But I'll probably leave that for a lab section and let those of you who are still working on getting your labs up to spec, more or less, get them up to spec. And those of you who are done and twiddling your thumbs can go ahead and put an optparse front end on your program. So we are actually at 12, and we've already talked about some of the items of 12. Or sorry, we're at 11. Wrong direction. 13. I'll get the right number here. We're at 13. It's a section entitled Functional Programming. We've talked about some of the items in the functional programming section, chiefly functions as objects. And we haven't talked about functions. We haven't talked about objects and classes in any definite form yet. We're going to do that hopefully by the end of the day. But it's just worth pointing out that Everything in Python is an object. Everything, every type in Python may have methods and attributes, and functions do in fact have methods and attributes. We've talked about the fact that they're first-class citizens, and that means that you can pass them as variables. When you pass functions to other functions, it's called higher-order programming, or kind of composing things by units. And we've done a couple little examples of that. I think almost everybody's done the filter example. We're going to look at that again with sorting today, and then this is going to be applied to your lab. So 13.3, if you want to take a look at that. I can't remember who it is that I was helping with the lab, and I noted that the built-in sort method on a list was kind of annoying because it was an in-place operation, and so I couldn't chain anything on it. There's also a built-in sorted, which has the same signature as the method, but it returns a copy. And we can use both of these. Python has good support for sorting, and its sorting is even kind of somewhat intelligent. So if I make myself a list of numbers, and let's do this in descending order. People have seen the range function before. It's a start and a stop, and it does take a third parameter, which is like the stepwise parameter in indexing lists. I can sort. I could also yeah, so there's the built-in reverse. Now I've got a list of letters. And again, if I do a sort, Python is sorting them in alphabetical format. And I could reverse them. But sometimes we have more complex data structures. What if I had tuples? How do you think Python sorted my tuples? It's looking at by default, it's looking at the first key in any iterable and using it to sort. So I've got a list of tuples, and they're sorted in ascending numeric order by the first key. But what if I really wanted to sort them by the second key? So yeah, you can designate that, and how you designate that is pass a function to the parameter key, and the function accepts the item that is being sorted and returns the value that you're wanting to sort. So does that make sense to people? I define a function that's called func, and it accepts, what does it accept? If I printed x inside my function, what would print? So x1 is the second value, but x itself is the whole tuple. This function is being called by the sort function and being passed each item successively. in my iterable. And it's figuring out what value should represent each item. Right? So each thing that it's passed is a tuple. It's a list of tuples. So I'm not looping at all. And basically, you can think about these sorts of approaches as doing away with the loop. Again, if you think about how I could do this manually, how could I make this sort work out manually? How would you write this if you weren't going to use the sort function? And let's not bother to do it in place, because that gets more complicated. Let's make a new list that's sorted. Nope. So what's being passed into func each time is each item in the list.
Right.
And each item happens to be a tuple.
Right. And return, what is going to be returning? A function?
And what it's returning is the value that should be compared to do the sorting, which is the second parameter in the tuple. And if I did this instead,
that were going to the key, that were equal to the key, right? Key.
that still works, right? I'm passing in a string. So each time, oh, and I'm sorry, I'm probably cutting off on your monitors. So it still works. I made a list that has strings. All my strings have at least 2 entries. And it could have however many, but they need 2 because I'm looking at the second one. And it has them sorted in ascending order by the second key. And again, if you think about how you'd write this yourself, you'd probably start out, well, we could do it in place and use a stupid sorting algorithm like a bubble sort. But it's going to involve a for loop and probably another for loop inside it to iterate over all the items, comparing them to one another. And instead, we know what value it is that we want to get. And Python has a really good, really smart built-in sorting algorithm. So why don't we just figure out how to extract the value we want and hand it back to the sorting algorithm? How about dicts? I actually have no idea how Python is sorting dicts by default, although it wouldn't surprise me if it's by the actual string representation of the dict, which, yeah, looks like it would work. It can't rely on the first key because there is no implied order to keys, like it did with tuples. But we could do our same sort of thing and write a function that takes a dictionary and extracts the value we want somehow. And here we even have heterogeneous dictionaries where the key is a different name. So I'll do something dumb. like that. Keys is a function. And I can sort them by the value. In this case, it's a dict that only had one key, so I just grabbed the first key, even though that's a dumb thing to do since there is no implied order. But hey, if there's only one key, then that key is always guaranteed to be the first key. So I keep on writing these little functions here. And that, especially when they're kind of one-line functions, that seems like overkill. Python lets you nest functions, so that kind of cuts down on the clutter. If it didn't let you nest functions, you might write a program and say you have like 10 different sorts, different places in your code. You'd have 10 different little one-line functions at the top of your code someplace that are sort of, the end user isn't supposed to call them. They're just little tiny bits of logic, and they're not anywhere near where they were defined. It's just kind of confusing clutter. So nested functions lets us sort of address that from a coding style and hygiene point of view. So I can define these functions right where they're used. But even that kind of bugs people. Why do I have to def and give it a name, and it's really only couldn't I just pass the statement that I want to execute, more or less? And in fact, you can. So Python supports in very limited form anonymous functions. It does so by a keyword and some new syntax. The keyword is lambda. So if you thought things reminded you of Lisp before, they really do now. And the syntax is lambda, my parameter list, no parentheses. So I'll say x. And a single Python statement whose value will be returned from my anonymous function. No return statement necessary. So what did I just do? I have a variable func, and it's of type function. Its name is lambda. It doesn't really have a name. I have a variable pointing at it right now, but I wouldn't have to. It's a function that accepts a single argument x and returns the first key of x. There's no return statement. There's no parentheses. It's all on a single line. I can't have multiple statements. It's extremely limited, but it's extremely useful for situations like, what is x right now? Let's get one of our earlier x's, like that one. I can just define it inline. And I really should give it different parameter names so I'm not, confusing everybody. This makes a good test, though. This x has nothing to do with that x. This x is the parameter name to a function, and it'll actually be one of the rows of x. So just like before, I was defining a separate function that accepted a single item from my iterable and returned the first index to allow it to be sorted. I've now defined an inline function. It has no name. I'm just assigning it directly as a parameter to the sort function. It has a very short function body that doesn't even have a return statement in it. It just evaluates the expression it sees and returns that value. So no, so this lambda form, there is no def associated with it. And how can I get to now that function that I just passed to sort? I can't. I have no name for it. I didn't bind any variable to it. I didn't put a tag on it. So it's actually hopefully simpler to read this statement. I'm calling the sort function, and key is a parameter that accepts a function, and I've just defined an anonymous function right here. If I instead said here x.sort key equals my sort function, and I'm going to get a syntax error because I haven't defined that. Well, that's a little more straightforward in that you know that I'm passing a sort function, but you have no idea how that sort function is implemented. And it might be further up in the page. It might be imported from another library. You don't know anything about it. Here, I've actually defined my sort function right there in line, and you can see what it is doing right where it's used. You can have more input parameters, but you can only have one single Python statement as the function body. It can be a complex statement of some kind, which means you can use logical ands and ors, you can use parentheses, you can use some of the tricks we'll talk about today,